Hi, Period 4 Pre-Algebra. This is the high school prep track. Welcome. Hope you're having a good weekend. Today's quote comes from Horseradish Bridge, Truths You Can't Avoid by Lemony Snicket, page 37. Most schools have a system of loud bells which startle the students and teachers at regular intervals and remind them that time is passing even more slowly than it seems. For Chapter 1, Lesson 2, the first thing we're going to talk about is order of operations. As a reminder, order of operations starts with grouping symbols, and grouping symbols can be fraction bars, parentheses, and brackets. So these are parentheses, and these are brackets. Alright? And when you have multiple parentheses and brackets in the same problem, you need to start at the most inward of the brackets or parentheses, because that's going to be the beginning of what you need to do. It does say exponents here for the next step, but we're not going to worry about today, so don't worry about exponents. And then next up is multiplication and division from left to right. Since multiplication and division have the same level of priority, we need to know when we need to do them. And so we know to do them from left to right because again they have the same level of priority. Addition and subtraction have a lesser priority to multiplication and division, but they have the same priority as each other. So addition and subtraction, same priority. So we need to know when to do them, and we need to do them from left to right. Okay, so let's go ahead and do a quick example problem. We've got two for the order of operations. As you can see, for the first problem, we have two sets of grouping symbols. Right there we have brackets and we have parentheses. So get rid of that real quick. So the first thing we need to do is we need to do the order of operations starting with grouping symbols. So we're going to see, and we've got brackets, but then once we're inside the brackets we need to say, alright, I still need to follow the order of operation. So then the next thing I need to do is still look at the grouping symbols. Okay, so the next thing is obviously the parentheses. So after the brackets come the parentheses. Can I do stuff inside the parentheses? Well, yes, I can. 8 plus 4 is 12, and since we've simplified the parentheses we can actually now get rid of them, but we still have what's going on inside the brackets. So basically I still have grouping symbols, so I'm still on this first step up here. I'm still on the grouping symbol step. So now 12 divided by 6 is 2, because if I've got 6 and I divide 12 into groups of 6, I'm going to have 2 groups. So now I've simplified inside of the brackets. I could turn them into parentheses, I guess, but they'll stay as brackets. And remember that when you have a number right next to a grouping symbol, it implies multiplication. Alright? So it's basically like 3 times 2. Well, 3 times 2 is 6. And that is my final answer. Don't forget to box your answers. Alright, for the next example, I want to talk about fraction bars. So fraction bars act as grouping symbols because normally in the order of operations you would take care of division first. And remember, fraction bar means division. Okay, it's just a fancy form of division. But since we've got this big fraction bar going on, it acts as a grouping symbol because it tells us that we don't do division first. We're actually going to do what's on top first and simplify the bottom first before we do any division. So the fraction bar actually tells us to do the order of operations a little differently. So the first thing we're going to do is we're going to go ahead and add the 6 and the 9. Well, 6 plus 9 is 15. Now that I've simplified the top of the fraction bar, I need to do the actual division. 15 divided by 3. Well, 15 divided by 3 is 5. Now that I've simplified that, I'm going to do 5 minus 2, which is 3. Box your answers, guys. Alright, last slide. Wasn't this so easy? Alright, the thing is this last slide has 2 ways to do something. So I'm going to show you the first way, and then I'll show you the second way. the first way to find the area of figures that are not regular polygons. So as you guys can tell, this little shape here is like L-shaped. It is not a full rectangle. If it was a full rectangle, it'd be very easy to find the area of it, because that's what we're doing, we're finding the area. Unfortunately, though, it's not a perfect rectangle. Alright, so we need to deal with it we can deal with it in two ways. The first way is to break it up into smaller shapes. So the first way you can do it is to look at this shape right here and this shape right here. Alright, well this shape right there, I'm going to deal with that one first. How about I use a different color? This shape right here has a length of 3. So I'll redraw it here. A length of 3 and a height of 4. Well, it is a rectangle, and it's obviously not a pretty rectangle, but you get the idea. It has an area of 12 because it is the length times the width, or in this case the width times the length, because the 3 is the width and the height is, the length is 4. However you want to do it, again, you can switch the numbers as you want, is 3 times 4, which is 12. So that is got an area of 12. Now this other figure, which I'll do in this green color, kind of looks like this, and it's got a 2 over here. The only thing is that it kind of stops right here, right? So it's not going all the way to 6. So this side is not 6. It's actually 3 because it's the full length of 6, but minusing the length that isn't the figure, which is right here. So that's minus 3. So this side is actually 3. Let me make that prettier. It's actually 3. So if this is 3, it's got an area of 2 times 3, which is 6. So to find the area of the whole figure, the area outlined in black, we're actually going to add these two. So it's going to be 12 plus 6, which is 18. So the area is 18. Okay, that was the first way that you can do this problem. Let me go ahead and show you the second way. But first I need to erase some of this. So we're no longer dealing with the first way. We're now dealing with the second way. So let me go ahead and get rid of this. Oh, we do need to remember that that's a 3 though, so let me write that back in. Okay, and then that one can go away, that one can go away, and this one can go away. Alright, so the first way basically has to do with figuring out the inside. And there's actually a way that I'm going to show you in just a second. It doesn't have to be pretty. The second way looks at the outside. Basically, it looks at the whole figure first. So, the outside, if we were to make this a perfect rectangle, we would add some part here and figure out the area of the total. That includes that purple little dotted line that I added. So if we were to look at the whole rectangle, it's got a longer side of 4 and a longer side of 6 on the bottom. Oops. Let's undo that. That's not what I meant. Okay, good. Maybe you didn't see that and only I saw it. Okay, so again, this side over here is 4 and this side over here is 6. So that would be if this was a perfect rectangle, if I turned this into a perfect rectangle, which means the area of this is 4 times 6, which is 24. There we go. And then the thing is that we don't want to count this area over here. We don't want it, right? Let me use a different color. We don't want this space. So we're going to have to subtract it. But to subtract it, we have to find the area of that space. Well, the area of that space is over here. If this long side is 4 and this short side is 2, basically we're going to subtract it. So this side over here is 4 minus 2 because we're dealing with this side right here. Okay? And then if we're dealing with this side, which I'll go ahead and make blue, it's going to be the longer side of 6 because that's the whole side right there, but we're not including this amount, so that's minus 3. So basically, to find the area of the thing that we don't want, right there, we don't want that, we're going to have to do some quick math. So 6 minus 3 is 3. 4 minus 2 is 2. So the area of this square is 3 times 2, which is 6. Well, if we take the area that we have total, if we had a perfect thing, and subtract the area that we don't want to keep, it's going to be 24 minus 6. Well, 24 minus 6 is 18. And if you remember from the previous example, the previous way, the first way, we did get an answer of 18. So that concludes it, guys. Have a good weekend and see you on Tuesday because you had a 3-day weekend.